And yeah, but we'll be talking about systems particularly as well for process plant safety. So they're a bit more complicated. So that would be interesting to see. All right. So can you see my screen
All right.
before we start?
Yes, we can.
Perfect. All right. So welcome everybody to this class. Today we'll be talking about fire extinguishing systems, particularly for process plant safety. So today we'll be talking we'll be starting with a quick introduction. Then we'll be talking about fire extinguishing equipment and systems. Then we'll talk about the selection of fire protection systems because it's not very easy to choose. Depends on what is the purpose of your system. Then we'll be talking about some fire protection studies and design considerations. And finally, we will conclude with a quick exercise to jog our memory, and finally the Q&A session to pertain to any questions that you may have. So let's begin. All right. So the first thing is why fire safety matters. Well, of course, first and foremost, it's for protecting lives. So fire safety is very important so we prevent injuries and fatalities caused by fires. Moreover, not only that, well, we like to safeguard our assets. So this means reducing the damage to costly equipment and facilities. As we know, if we have a fire in a process plant or generally anywhere, if the buildings are being destroyed or damaged, that means millions and millions of dollars being lost. Then we will also consider the environment because fires are very harmful to the environment if not controlled. They could damage ecosystems. So mitigating risks of hazardous material spills due to fires. And lastly, also for the business continuity, because if a process plant, for example, faces a fire, this means that we will have to close and shut down the plant, and this will reduce in a lot of downtime and economic losses. All right, we need to understand fire risks in process plants. So how can a fire start, basically? Well, we know that in process plants, we have a lot of flammable materials. So this means fuels, gases, and volatile chemicals, especially in the oil and gas industry, where we're dealing with a lot of flammable materials. Then we need to understand the potential sources of ignition. So how can a fire be ignited? So for example, we have electric equipment, we have static discharge, we have heat. All of these things could be the reason for the source of ignition. Then we need to analyze, okay, what are the risk areas that we have or the high risk areas that we have in our plant? So this means the storage tanks where we store all of this flammable equipment, flammable material, and also our processing units and the loading and unloading zones. So where the truck comes and loads all of these flammable materials, these could be high risk areas that we need to particularly focus on. So just to give you an example, a refinery unit with flammable gases is prone to rapid fire spread. So this is very important to ensure that there is no ignition near that refinery unit. Now we would like to clarify two different definitions: fire prevention versus fire suppression. So a lot of people might be confused by these two terms. So fire prevention means minimizing risks of ignition. So examples include we check the equipment, we have proper controlled storage, so we try to prevent the fire from happening. Whereas fire suppression, on the other hand, it is containing and extinguishing the fires after the ignition. So examples include sprinklers, foam systems, CO2 suppression. So this is after the fire has already been there. How do we suppress it? So an example would be, the ideal case would be to have a balanced approach between these two. Both prevention and suppression are necessary. We need to ensure that we prevent it as best as we could, but in the case that this fire still exists for some other reason, we need to ensure that we have proper systems in place that can suppress this fire. All right, now let's talk about type of fire protection measures. So we have passive systems. So passive systems include the fireproofing coatings, like the one you can see in the image, the fire barriers, and compartmentalization. So we ensure that we have barriers so that we don't experience the so-called domino effect, where if one equipment area goes on fire, the fire doesn't spread so easily. So we need to ensure that we have fire barriers and proper compartmentalization. As for active systems, these include sprinkler systems, deluge and foam systems, and also CO2 and inert gas systems. So an example of this would be a combination of fireproof barriers and deluge systems from a flammable liquid storage area. So we have both systems. We have a passive system and also an active system in place. With that being said, now let's talk about some specific fire extinguishing equipment and systems. So fire extinguishing and process plants. So first we have the water-based systems. So these include the fire water rings, hydrants, sprinklers, and the deluge system. So we have 4 specific water-based systems. As for the foam-based systems, we have the foam water sprinklers, the high expansion foam, and the fixed mobile foam monitors. As for the gas-based systems, we have the CO2 systems, inert gas systems, and also the halon alternatives. And finally, we also have dry chemical systems for specific scenarios where we need to have dry chemicals for suppression. We have localized protection for high-risk areas. So to show you an example of how each of these systems look, as you might not be very familiar with these terms. So the fire water rings is basically a continuous water supply for fire suppression and cooling in the form of a ring, as you can see on the bottom left of the slide. Then we have the fire hydrants and ground monitors, which are high flow systems for firefighting. So as you can see in the picture, it's a sort of hose that you can, but that is fixed, and you can use it to extinguish fires from a very far location. Then we have the sprinkler systems, which are not only in process plants, but everywhere. So for example, in your offices, you would see that you have these sprinkler systems in place, which spray water to control localized fire. And finally, we have the deluge systems, which are a bit more complicated, which have a whole system of rapid flooding of an area with water. So a deluge system would ensure that, and these are very useful for process plants, where if we have a fire, it will flood the whole area with water. So let's maybe take a look of a fire water system here in place. So I have this
Ciao, sono Yuri.
here.
Perché noi compriamo Auto.it? Sono quelli che pagano meglio.
So sorry for that ads. Maybe we can see a quick video of a fire water ring system. So if you look at this, this is a process plant, and you can see that at a certain point, the fire water ring will be initiated. So let me just proceed with the video. So for example here, you see that the fire water ring is being activated around the storage tank. So if there's a fire happening, it will be prevented using these fire rings that are around the storage tanks. So these fire rings will be spraying at a very high pressure and velocity, as you can see. And this will be to contain any sort of fire happening. So this is just to give you an idea of how storage tanks can be protected with the fire water ring systems. All right, so let's proceed. Now the next video I have is one for a ground monitor system. So a ground monitor system, as you can see, is how it looks here. It's basically a device that can be used to spray water at a very high pressure and velocity as well. So let's say if there's a fire happening there, then there will be operators controlling the ground monitor systems to try and extinguish these fires. So you can see here we have these systems that can be controlled by operators. So there are 2 types of monitors. We could have either an operating an automatic one or a manual one. So in this case, the one we see here is where it can be controlled by the operators. Okay, so this is for the ground monitor system. Now let's look at the fire water ring system as well, another example. So here we have, I can just show you. So here we have the beginning of, you can see now that the fire water ring starts. And naturally, the equipment itself is very dirty, so you can see that a lot of dirt is being washed by the water. But this is an example of another fire water ring system. Okay. And lastly, we have the deluge systems that we're talking about. So the deluge systems are a bit more complicated in the sense that there are more water happening, and it's for more serious, let's say, fires. And here you can see that the deluge system is in operation, and it's flooding the whole area with water from different from different areas, as you can see. So this is how a deluge system would look like in a process plan. Mm. Okay. All right. Now let's move. So we've talked about the water-based fire extinguishing systems. Now let's talk about the foam-based fire extinguishing systems. All right. So we have, as we said, we have foam water sprinklers. So these are sprinklers like the water, but they combine foam and water to suppress the flammable liquid fires. Then we have also the high expansion foam systems, which can be used for confined areas like tanks or warehouses, as you can see in the image. And lastly, like the water monitors, we also have the foam monitors, which can directly apply foam for liquid fire suppression. So let's take a look at an example of a foam water sprinkler system. So here, as you can see, the water and foam are being, this is to spread the fires of certain chemicals which require the foam to suppress it. So in specific applications. So you can see the whole building would be flooded by these foam water sprinklers to ensure that all the areas are covered and that the fire does not spread. So, okay, moving on, we have a high expansion foam system. So just to give you an example of how it looks like. You can see that these equipments, the red ones, are literally spreading out foam, and you can see that it's slowly filling the room.
You know, it just seems like magic
Yeah, it's,
to have so much foam coming out of a cylinder just constantly.
yeah, it is very interesting to see.
Is this system better, you think, because it's a thicker foam?
Yeah, I would say compared to to the fire or the one we just saw, the sprinklers, yes, for sure. But of course, this depends on the area and the type of fire that you would like to suppress. So maybe in certain systems, because now this one is just strictly foam. The other one was a mixture of water and foam. Because it helps to, basically the foam helps to cool and prevents the release of these flammable vapors. So this is why in some certain applications, water alone will not be enough. And lastly, here we can see an example of the mobile foam monitors. So they're similar to the water monitors, but they also have water, they have foam. And you can see that the pressure is very high.
Available with a simple press and rotate mechanism for flow setting. Especially useful where light pressures may vary and affect performance of monitor.
So as we saw, these were example of the foam-based systems. So they're kind of similar, apart from the one that was exclusively foam, but the monitors and the sprinklers are similar in the sense of their mechanism. It's just that the material being sprayed would be a mixture of water and foam. And then moving on, we have another type, which is the gas-based fire extinguisher systems. Because, for example, in an electric room, you cannot really use water to extinguish a fire there. It would be damaging and it would be catastrophic. So in some areas, you need to use gas-based systems. So these gas-based systems could be CO2 systems, which displace oxygen in the enclosed area to suppress the fire, because as we know, a fire requires oxygen to continue. And if you just suppress the oxygen, then the fire will die out. Or we could have inert gas systems, because in some cases, CO2 systems, especially if there are operators there, it could be harmful to humans to inhale a lot of CO2. So this is where we would use different types of gases. So we can use argon, nitrogen, or clean agents for fire protection. So this is also ideal for sensitive equipment like the server rooms, for example, which have a lot of information that needs to be left unharmed. And then we also have the halon alternatives, so environmentally friendly gases. So it can be used in high-tech facilities. All right, so this video shows a quick example of a CO2 fire extinguishing system. You can see a lot of chambers. So these are the storage tanks for the CO2. So after a certain point, the sensors will detect the fire, and then this extinguishing is going to start. Okay. Then we also have dry chemical and powder systems. So these are used for electrical panels, flammable liquid areas, for example, powder extinguished in the control rooms. So they're very similar in the sense of how they look, but if you can see closely to the material, to the powder, it's slightly different than CO2 in the sense of how it looks as well. So for example, if we look at this quick video, this is an example of a trichemical fire extinguisher.
This is an ABC extinguisher, which is a dry chemical. ABC means it's multi-purpose, so it can put out any number of fires.
Yes, so we have actual categorization for types of fires, so A, B, C, E, D, and so on. So this is important because every type of fire differs. Is it a pool fire, jet fire, and so on? So it's important to know which type of fire the extinguisher can put off. So you can see the consistency of the powder is slightly different than the CO2, perhaps you can notice. Okay, so this was just a quick demonstration. All right, so now let's try to have a sort of summary of all the systems. So we said the water-based systems, the key feature is that it has high flow, continuous cooling, and rapid response. And typical applications will include the storage tanks, the pump areas, and the warehouses. As for the foam-based systems, it combines both foam and water for liquid fires. And it's also can be used for chemical storage and confined spaces where where the foam would be required to put off the fire. Then we have the gas-based systems, which is it works on oxygen displacement, so it basically removes the oxygen to cut out the fire. And this could be useful for control centers, server rooms. And finally, we have the dry chemical systems for a quick localized suppression. And this could be applied in electric panels, small flammable areas, and so on. Now let's talk about the selection of fire protection systems. So how do we how do we choose the best type of system for our fire? Because I'm sure you're quite aware now that we have different systems, but how do we really know which system to apply? Well, first we need to understand what are the factors affecting the fire protection system choice. So as I was telling you, there are different types of fire hazards, A, B, C, that are defined by the international standards. So class A means it's an ordinary combustible. So for example, wood, paper, cloth, and the approved fire extinguisher will be type A or type AB. Then we have class B, which include flammable liquids. So example, gasoline, oil, grease, and the approved fire extinguisher would be AB, BC, or a type ABC. Then we have class C, which is electrical equipment fires. This one is when we have electric equipment, of course. And then class D is the combustible metals. So for example, magnesium. And lastly, class K is the cooking oil and fats. So the commercial cooking oil and appliances that, for example, that we have in our homes. Okay, and then another factor is the fire load. So the quantity and the type of combustible materials present. So for example, a higher fire load in a chemical storage tank because we have a lot of flammability there. Then we also assess the risk level. So for example, the risk assessment of specific area. So the risk in a reactor will be, of course, different than the risk in an office. So we have to check this and take it into consideration. And lastly is the resource. Also, we have the resource availability. So the water supply, how much water do we have? Is this water enough to take out the fire in this area or not? What about the foam storage? What about the gas system refills? Is the gas enough to put out this fire for this, let's say, this storage room or not? So all of these factors need to be taken into consideration before choosing your fire extinguishing system. Then as for the application areas, so where do I put the system? Okay, so I know maybe what type of systems to use. Where should I place it? So first for the storage tanks and the bonded areas. So for storage tanks, you can put water deluge systems, you can put foam monitors, you can put fire water rings. So for example, to protect a large oil storage tank, we can use the fire water rings as we saw in the video. Then we have the processing units. And we can also put the sprinkler systems, the foam systems, and inert gas systems. This could be protecting the distillation columns or the compressors in our process plant. As for our electrical rooms and control centers, as we said, we cannot use water. So the systems that can be applied are CO2 systems or the inert gas systems. So this is to ensure that the sensitive equipment isn't damaged by the water or the foam. So choosing the right fire protection system. So for class A fires, you can choose water sprinkles and deluge systems. For class B fires, however, you can use foam-based systems or dry chemical systems. For class C fires, you can use CO2 systems and inert gas systems. For class D fires, you can use specialized dry powder systems. And lastly, for class K fires, you can use wet chemical systems, for example, in the kitchen environment. Okay, so what are some practical considerations for our system selection? Well, as I said, a very important thing, especially if you have a water-based system, is the fire water availability. You need to ensure that you have adequate supply for water-based systems, so the rings, the sprinklers, and the hydrants. Then also the environmental impact. We need to choose eco-friendly options. So for example, halon alternatives, inert gases, and also we need to consider the plant layout because some systems might not be adequate to fit in a small area. Let's say if I have an office, I cannot really put a lot of big systems that take a lot of space. And also, especially for the monitors, you need to ensure that you place the monitors in a strategic location where the water flow can reach your desired or designated extinguishing area. And lastly, but not least, the regulatory compliance. So of course, you have to comply to the international standards, such as the NFPA, API, which is the American Petroleum Institute, and also the Occupational Safety Health OSHA standards. So these are all important to keep in mind. Okay, now let's talk quickly. Just there's a lot of fire protection studies, and but I would just like to show you a couple and basically give you a brief of why and how they're conducted. So first we have the fire risk assessment and the water demand. So the fire risk assessment, what we do in this study is basically we first identify the high risk areas. So for example, if we have a flammable material storage or we have some processing units that could be prone to big fires, then these will be at the high risk areas. Then we would assess the potential hazards and gaps in the existing protection. So we check our current protection and we have to determine, okay, what is remaining or what are some weaknesses and gaps in our current protection systems. Okay, and then for the fire water demand calculation, we need to determine the water flow rate based on the fire scenarios and the plant size. So how much water will be required in our case? And then this will include the pumping and storage capacity for the worst case scenario. So we need to ensure that we have a backup storage where, let's say, if the fire goes on for a certain amount of time, our water will be able to sustain this extinguishing period. So for example, a refinery will calculate around 12,000 meter cube of water storage for firefighting. But of course, this depends on your plant size. Then we have the hydraulic analysis and system design. So for the hydraulic analysis, we will simulate the water flow and pressure to ensure consistent fire water capabilities. We will also address the bottlenecks with high capacity pumps or booster systems. So because pressure is a very important part when it comes to extinguishing fire systems, and we need to ensure that the water pressure is always maintained, because if the pressure is reduced, then the extinguishing will not be possible. In fact, if we just add water in a very low pressure, that would be worsening the situation rather than extinguishing it. And then we also need to consider the design considerations. So the coverage of the hydrants, the sprinklers, and the monitors for all the critical areas. We need to ensure that our systems are designed in a way that could reach all the areas of our desired extinguishing. And also we need to have redundancy. So we need to have backup pumps and valves in case of sudden failures. So to ensure that we have the reliability in certain situations. And of course, as I said before, we need to follow the industry standards like NFPA and the APIs. Then we also have the fire hazard modeling and practical insights. So let's say a fire happens. How do we know how it will behave? So we could do that by using computational power and tools like CFD to simulate the fire spread, the heat release, and the smoke movement. This can also tell us the radiation area of the fire and until where people will be safe or damaged. Then we also need to evaluate the suppression system effectiveness under different scenarios. Let's say some systems failed and so on. We need to see, okay, where would the fire be spreading? So for example, we can have a tank fire simulation test, foam system coverage. And then we need to have case study analysis. So chemical plant design, including fire water ring, foam monitors, and hydraulic analysis. We ensure that the fire protection and regulatory compliance is being considered. So with that, I come to the conclusion of today's lecture. So to summarize, importance of fire protection. We see that effective fire protection systems are essential to mitigate risks in process plants. It's important to protect lives, assets, and the environment from catastrophic fires. The system selection, we see that the fire protection system should be tailored to the specific hazards, considering the plant layout, the fire risks, and also the available resources. As for the design studies, we saw that there are different comprehensive studies, including the fire risk assessment and the hydraulic analysis, which are critical for the system's effectiveness. And we also saw that accurate fire water demand calculations and hazard modeling will ensure that we are prepared to face such scenarios. All right. With that being said, now we will move on to a quick exercise of MCQ questions to jog our memory. So please feel free to participate and give your answers in the comments as we proceed. So the first question is, which of the following is a passive fire protection measure? Is it A, fire sprinklers, B, fireproof barriers, C, CO2 suppression system, or D, a foam monitor? So we have a C, we have a D, we have a A. Okay, so far different answers. Okay, so we have a bunch of B's right now, some A's. Dr. Lambert, what do you think the answer may be?
So yeah, we're looking at a passive fire protective measure.
Yeah.
So it's not active.
Correct.
I'm going to wait for everybody else to get their answers in here. Do you think everybody's answered so far?
Maybe we can wait for another minute. Let the others answer as well.
I would venture to guess B, the fireproof barriers. But it might be C. But it might be D. So there's certain
Okay,
most
so
of the answers seem to be B and
B.
D. What do you think? Want to give us the answer?
All right. So I think we've built enough suspense. So
Yes.
the answer is yes. So as Dr. Lambert specified, this is a passive fire protection. So we're not talking about active. And for passive protection, it's a fireproof barriers. So it's something passive that we do beforehand to prevent the fire from happening. So the answer is B, fireproof barriers.
Yes, passive kind of means preventative, right?
Yes, exactly. So passive is more on the preventative side, whereas active is more on the suppression side. Yes. All right. Thank you all for your contribution. Let's keep it up for the second question. So the second question is, which fire suppression system is commonly used for flammable liquid fires? I repeat, which fire suppression system is commonly used for flammable liquid fires? So not normal fires, but flammable liquid fires. Is it A, water sprinkler system, B, a dry chemical system, C, a CO2 suppression system, or D, a foam-based system?
Okay, we have some answers coming in already. I wrote down question 2 in chat so we could separate question 1 from question 2.
Yes.
Ooh, a wide variety of answers here.
Mm,
No one's saying C so far. Oh, we have a C coming in. So we have all four. That's a perfectly crafted multiple choice question when everybody answers at least one of the answers.
uh, try to make it slightly tricky.
Yeah. I think of something, I think of water, a liquid fire spreads on the ground, basically. So you're going to need something to cover something that flows with the liquid to
Yes,
suppress it.
I like that way of thinking. Yeah, that's something to take in mind. Yes, because
So
we are
I
not
would
gonna.
rule out dry chemical system because it doesn't flow with the water or with the
Correct.
liquid. And then water is something you have to be careful of too, because sometimes water will kind of exacerbate, kind of worsen some fires that are liquid based.
That's true. Okay, so let's take a look at the answers. So we have C's, we have B's, we have A's, we have a D as well.
We have a
Let me
D.
know. Yes. Okay, so I have a couple of D's and A's. So has everyone answered? We are ready to hear the answer. Okay, so the answer is So as Dr. Lambert pointed out, it's a flammable liquid fire, and we need a sort of system that can spread quickly to cover the range of the liquid, because as we know, liquid will spread very quickly. And to do so, a foam-based system would be the best in this scenario, because as we saw
Yes.
in the videos, the foam quickly spreads around to cover the whole area. So in this case, a foam-based system would be the
Yeah.
best flammable liquid fires. Okay.
And it'll ride on top of the liquid.
Exactly, yes.
Perfect.
All right.
That was a great question.
All right. Let's hope this question as well is interesting. Okay. Perhaps this one is a bit simpler, but okay. Question number 3. What is the main purpose of a deluge system and fire protection? So is it cooling down the machinery? B, rapidly flooding an area with water for fire suppression? C, displacing oxygen to suppress fire? D, providing portable fire extinguishers? So if you remember, I've mentioned this in the lecture previously. So what is the purpose of a deluge system? I mean, why do we need it or instead of a normal fire ring or a sprinkler system?
Okay, so far we have a predominance of B. Is this question just easier, or is this a really tricky question? Oh, we have.
No, I think this is an easy question, I would say, you know.
Yeah. Because a deluge system, one of its purposes is cooling down the machinery.
Yes, that is true. That is true. But you can also cool it down with the fire ring system. And you can also cool it down with a monitor. But so I would say I would say A is not completely wrong, but it's not the most appropriate answer, I would say. So maybe let's filter out. I helped you guys. There's no A. It could be B, C, or D. Okay.
And so
So
you
maybe
think of a
we can,
deluge system coming from up above, like a rain, right?
yeah. Yeah, so it's not exactly like a fire. No. The one that is a rain is a fire water ring system, but the deluge system is water from every side, top, left, right, as much as we could. That's how a deluge system would work. As we saw in the video, for example, it was from the right, from the left, from the top. So it's not only from the top. So it's to ensure and the reason why we do this is because we'd like to. The answer is B. So we'd like to rapidly flood an area with water for fire suppression. So a deluge system, how it works is that we try to flood the area as much as possible from different angles and different sides. So this is how it works. Okay, sorry, let's go to the next question. Question number 4. So which factor is the most important when selecting a fire protection system? Is it the plant's location, the type of fire hazard presence, the number of employees, or the age of plant? Now remember, which factor is the most important, okay? So of course, there are lists that are also important, but which one would be the most important to consider? Okay, so we can see a lot of B's.
This is an interesting question because if you choose B, that's basically saying none of the other options there are really that important.
I would say when you talk it depends on how you're looking at the import. Are you talking about the fire protection system or generally about the protection? Because of course, if you talk about the protection, then the number of employees, the plant's location is important. But if I'm talking about the type of system, okay, is it a water base? Is it a foam base? How do I choose my system? The number of people is irrelevant, for example. So the answer in this case would be B, because we need to know the type of fire hazard that is present. So before being able to protect ourselves, we need to know what we're protecting ourselves from, exactly. So for this case, we need to know the type of fires. As I said, if we have a flammable liquid, and doesn't matter how much water we use if it's not going to be effective. So we need to first know what we're dealing with, set the proper system, and after we choose our system, of course we need to consider, okay, what is the location, how do we seclude and evacuate people, and these are all alternative things that will be considered as well. But right now we're exclusively talking about the fire extinguishing protection system. So of course, this topic is it could be extended. It's not very. I mean, I'm not giving its full right by just talking it in the sense of like fire protection system, but there's a lot of things being considered. There is quantitative analysis. There's also the explosion that we haven't talked about, because fires could lead to explosion, and that itself is also an its own topic. Maybe in the future we could talk more about that. So there's a lot of things to consider when it comes to fire protection. But in today's lecture, I just tried to focus on such a small portion in process plants. Okay, now we have the final question before we go to the Q&A, which I'm sure you guys have a lot of questions to ask, and I would love to answer them. Okay, so question number 5. What does a fire water demand calculation determine? So I believe this one is quite simple and easy. So is it A, the amount of water required to extinguish the fires, the number of fire extinguishers needed in a plant, the temperature at which fire suppression starts, or the type of firefighting foam to be used? So fire water demand calculation.
This question is a little tricky.
I would say, yeah, A and B are tricky, I would say.
Yeah.
Yes.
Because in a sense, it's hard to separate the number of extinguishers from the amount of water.
That's true. That's true. Yeah, so with the fire water demand calculation, you're right. So maybe I could have phrased the question much more better, I would say. But in this case, the answer would be A. So we would like to calculate the amount of water required. But based on this water required and the pressure of our extinguishing systems, we would know how many number of fire extinguishers to put as well, which is something that, yeah, as Dr. Lambert pointed out, is also a part of the fire water demand calculation, but it's something that is done sequentially after. So first,
Yeah, it's kind of like a secondary
yes, it's a second
calculation.
thing. Yes, it's a second type of calculation. So maybe, yeah, so that could be, as I said, there's a lot of studies, especially for fire water, that's done in the industry. But for example, for our fire water calculation, when we do the report, we find the total water needed and also the volume of the storage tanks to contain this water, and also the time that this water can last. For example, the standard says that for 2 hours, you need to at least have storage that can maintain 2 hours of extinguishing, which is a very like a rule of thumb from the industry. But of course, it changes based on the plant and the process and a lot of factors. Yeah. All right. So
I have
with
an
that,
interesting question that maybe
yes.
we can